Hello everybody, Morgan Lewis here. Today's video is on working out resultant forces of an object. We're going to work out the resultant force, the direction of that force, and most importantly, the angle of that resultant force using sine, cos and tan. Hey, so get a cup of tea, get some lemon squash, hit the like button, hit the subscribe button, get a pen, get a calculator, and let's get into the video. Right, I hope you got your tea or your squash. Actually, before we start. Right. So, calculating, I'll just write with this pen. Calculating. We're going to calculate, right? Resultant force. Resultant force. That's going to be in newtons, obviously. We're going to work out from that as well its direction, and what I mean direction. Is it going like that? Is it going like that? And then we'll also do the angle, because we can also do the angle measured in degrees. Alright, so calculating all of these, resultant, direction and the angle. Scroll down a bit. So one thing just to remind you is that, let me get a different color pen here because we will see it in a bit. Obviously we can have a force on a part. We could have it doing this. That's easy because it's horizontal. That's easy because it's horizontal. We can add it up. Same thing with this. If it's vertical, we can easily add it up. Because don't forget, we've got to add things up. So we can add up the sum of the forces. Sum of, all we can do is add them up. Forces in the horizontal direction, and we'll also add up in the vertical direction. That'll tell us the resultant force. So we'll be doing that, just as a quick reminder. Don't forget, everything coming up we'll call positive. Anything coming to the right we'll call positive. Anything coming down and to the left we'll call negative. It's not a negative force, it's just one's going one way, one's going the other. So we've got to make the distinction. So when you see me do plus and minus, that's what it is. And don't forget as well, which is on one of my videos, if I've got a force like that, which we will have, and say it's got an angle, morning angle, name the film, right? Say if this was, I don't know, 10 newtons, and this was 33 degrees. Don't forget, we can't just put the 10 in the grid. We've got to convert, or we've got to work out its horizontal component and its vertical component. Every resultant force will have a force in the horizontal. It will also have a force in the vertical, because it will. Now, I've shown how this works in a previous video on my YouTube channel here somewhere. But at the end of the day, this is what you need to do. Let me scroll down a bit. Using this angle from the vertical, this angle from the horizontal and this force. If I want to find the horizontal force, I'm going to be doing F cos theta. And if I want to find the vertical force, I'm going to be doing F sine theta. That'll be in the angle. So it looks something like this on the calculator. So F cos theta, obviously in this example it's 10. So we can do 10 cos, the angle is 33. So 8.36. all that means is that the horizontal component of that 10 is 8.3 something, whatever it was, 8.39, say. That's all it means. And then the same thing with the sine one. To work out the vertical component, I just do this. 10 sine 33. No. Plus equals 5.44. That just means this here is going to be 5.44 newtons. Just to make sure you're clear on that. And all that really means is, if you want to make it even a bit better, is this. If this was me and I was pulled up in that direction by a force 5.44 directly up, and I was also pulled in this direction 8.39 newtons, the resultant force of them two forces would mean that I go that way 10 newtons at 33 degrees. I'm going to put here NTS. Do you know what NTS stands for? Not to scale. And if you don't believe me, you could just draw this triangle. You could draw that. You could draw a line 8.3 centimeters long, or 8.3 miles long, or 8.3 kilometers long. Just do 8.3 centimeters, if you like centimeters. And then if you drew a line up 5.44 and then joined all these up and completed the parallelogram and drew that line, it should equal 10, and measured it, it would be 33. That's what we've covered in previous videos or previous working class, or if you're not in my class, hopefully you've covered it in wherever you are. So, that being that, more tea Vicar. Here's an example. Let's do an example which we'd have done in class, but let's do another one. I'll do one which is going to be very similar to things that you'd have seen. So let's do this. This is a L-shaped bracket. You may ask why it's an L-shaped bracket. Because it's in the shape of an L. So this could be anything, right? What I'm going to do is, because this is all part of it, I'm going to put I'll put a force here. I'll put a force there. So it's been pulled this way by 3 kilonewtons. It's say being I don't know. There's a force pushing down on it there. Let's say 7 kilonewtons. And I'll put another force over here. Let's call this one, I don't know, 5 kilonewtons. Only forces, right? And let's do an angled one, because you're going to get an angled one. The angle, this can be, say, 10 kilonewtons. So it's coming down, and the angle there, let's say, is, I don't know, 61 degrees. So we've got to work out now this, we've got to work out the resultant force of this. All these forces on this L bracket, what's the resultant force? If there is one, because there may not be one, which way is it going to go? Up, down, left, right, southwest, northwest, whatever direction. Which way is it going? And the angle. So that's what we're doing. Don't forget, this one's quite an easy one because it's vertical. This one's quite an easy one, it's horizontal. This one's quite easy, it's horizontal. We can add these up in the grid, nice and easy. This one here, what we'll have to do is we'll have to convert this now, force, horizontal. We have to work that out, which we can, and we'll have to work out FV, the vertical force, using F cos and F sine. No trick here, no trick. So what I might do is I might just do that first. Let's get it out the way. So what we've got is we've got this. We've got, let me just scroll. I'll do. So we've got a force really like this, coming down like that at 10 kilonewtons, and the angle in here is 61. So F is 10 kilonewtons. You haven't got to put the 10,000 in, you can put it in at the end. And the angle is 61 from the horizontal. That's what we use. So if I want to work out now, which I need to do, if I want to work out this here, which is the horizontal component of that 10, I'm going to be doing this. F cos theta. F cos theta. F cos theta, horizontal, F cos. Using the way we use it. Which means I'll do it down here. So I'm going to put the numbers in. F H F cos theta. Well, we know that F is 10. Right, I'll leave the K out for now, I'll put it in at the end. Cos is cos, because it is. And the angle is 61. Stick that in your calculator, right, and you should get something like this. 10 cos 61. 61. Sound like a bingo caller. Plus equals, that gives me 4.8. I'm going to call that 4.85 just for a laugh. 4.85. 4.85 kilonewtons. Measure twice, cut once. Let's try it again, just in case. Let's do cos of 61 equals that times by 10. 4.84. Obviously, you could put all of that in, but I'll just go 4.85 perhaps. You may not like that, but it's up to you. So that is the horizontal component of this 10. And that's the number I'm going to be using in a bit. So that one's done. And now, obviously, we've also got one that comes down here. I'll do a different color. What color do you want? Anyone will do? No, let's do a... Oh no, let's do a green. Hulk. So this one is going to be the vertical one. FV means vertical. So we're going to be doing this. FV is going to be F sine theta. Just like up here, look. Everything going up or down is going to be sine. Sin, sine, right? Using this, the angle from the horizontal and the force. I know that F is 10 and sine is going to be sine and the angle is going to be 61 again. Stick it in your calculator. Alright, so 10 sine 61, make sure you're not in radians. That gives me 8.746. 8.7, I go 8.75 just to check that again. Let's do sine 61 equals that times by 10. Gives me 8.75. That'll do me, John. 8.75. 8.75 5. Don't forget the killer newtons, please. 7, 5. Killer newtons, don't forget that. Now obviously this is not live, but do you agree with that? Say yes, I do. Well done. If you don't get the answers on your calculator, it's because you could be in radians. So just make sure you're not in radians. Now what that means is that this is this. Let me scroll down. So we've got a force going that way, which is 4.85. Bearing in mind, this is going to be a negative soon because it's going that way. Yeah? We've got 4.85 going that way because we worked it out, horizontal. And we've got a force coming down here, the vertical one of 8.75 kilonewtons. Right. Let's go back to this. Right. Now, we've just worked these out. 4.85 and 8.75. Okay, now, but if this was you, and you were being pulled this way, 4.85 kilonewtons, and you were being pulled down, directly down, right, this is 90 degrees by the way, 8.75, the resultant force would be what? Da, 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 da. What would it be? Put your hands up. It's going to be 10 kilonewtons, 61. So you would go something like this, wouldn't you? Not to scale again, right? 10 kilonewtons, 61. Let's do it then. Oh, no. 61 degrees in there. Ignore all that mess. That's what it means. But we've just broken this down into forces, right? So now I've done that. So I can tick this one off because I've sort of sorted it out. I know these numbers now. And the numbers are here, aren't they? 4.85 and 8.75. So what I'm going to do now is add them all up. I'm going to add this one, and these ones, and these ones. I'm going to create a grid, horizontal and vertical. So, bear with me. Now you haven't got to use a grid like this, it's just that I do. So I'm going to have the force there. I'm going to have the force H. What does H stand for? Horizontal. Alright. Force. What does V stand for, Morg? Vertical. And then I'm going to add in all of these forces, add them all up. So the first one I'm going to put in is this 7. Don't forget this, just in case. Everything going up on that way is plus, everything coming down is minus. So this 7 is coming down. This 7 is coming down, it's vertical, and it's coming down. So I'm going to put minus 7. So I'm going to do this. 7. It's not going horizontal, is it? It's going down. But it's got a vertical component and it's coming down. Minus. Now you haven't got to do it like that. You haven't got to bother putting in, this note by here. But so that's that 7 one. It's coming down, minus 7. It's not floating, it's just coming down. That's the direction. So tick him off. Done him. Number 5. This 5 here. It's going horizontal. So there's no vertical. It's going horizontal and it's going this way. It's going to the left. So minus. So I'm going to put, let's do it here. Let's do a different color. Different color. I'll put a 5. It was not going vertical. It was going to the left. So I'm going to put minus 5 in there. It was 5, wasn't it? Yes, there we are. 5. It's going horizontal. That's why, and it's going this way, and I'm calling anything going that way negative. Don't forget as well, what we should do is we should put the units in here, because these are kilo newtons. This is also a kilo newton, and this is also a kilo newton. N for Isaac Newton. 1, 2 forces. Let's go up, let's go up, let's go up. So I've done the 7 and the 5. I'll do the 3. The 3, get a different colour for the 3. The 3 is going this way. It's going horizontal, and it's going in the positive direction, because this is positive. So it's going to be horizontal and positive 3. So I'll do this. I'll do a 3. It's not going vertical, but it's going horizontal, and it was a plus 3. So that's that one. The 5 and the 3 and the 7. Ready, Benny? Right, bang, that one. Done that one. So 7's coming down and minus. 7's coming down and minus. The 5 is going across, horizontal and minus. Yep. And the 3 is going across and it's horizontal. Always check. That's them. Now the last one to do is this little beauty by here. The 10 and the 61. So I'm going to put the 10 in. What colour do you want? Not that you can vote. So I'm going to put the 10 in because we have got it. It's 10, right? Now we can do this. We can put a line down here now. So there's my 10. Now, don't forget we worked out the vertical and the horizontal component of this 10. And that's what we're going to put in. So here's my 10. We worked out the horizontal was 4.85. Right? It's going that way as well. Right? Don't forget it's going that way because it is. It's going that way. It's going that way horizontally, which we call anything going that way is plus, anything going that way is plus, minus, minus. So it's going to be going that way. It's going to be 4.85 horizontal minus because it's going to the left. So horizontal minus 4.85. Just check horizontal minus 4.85, horizontal minus 4.85. It's 4.85 and it's going this way, which means it's going in the negative direction. And then there's my 10 again. So the vertical one, the vertical, it's going 8.75 because we worked it out here. 8.75. It's coming down, so it's coming down like that. So anything coming down is a negative number. So I'm going to put in minus 8.75. That's not a negative force. It's not like when you're floating on the pirate ship in Oakwood somewhere or in the theme park. It's just the direction. So minus 8.75 vertical. Minus 8.75. And all I've done there is I've just put in the vertical and horizontal component of this 10. Everything else was angled. Everything else was easy, like 7, 5, and 3. So either going vertically or horizontal, it's easy. This one, we had to work it out. We had to break this 10 down into horizontal and vertical. And then whack it in the grid. So, hope you're okay with that. Have another swig of squash or cup of tea. What we've got to do now is, I'll do it actually. What we've got to do now is we've got to add all these up, which see who's winning. So here we go. Is a posh thing. Sum of, that means sum of. All it means is add up. So all I'm going to do now, I'm going to add this and this and this and this together. Right. And I'm going to add this and this and this and this together. So make sure you put in your negative numbers, right? So naught, obviously, so I'm going to put minus 5, if you want to put a bracket on it. Minus 5 plus 3 plus minus 4.85. So minus 5 plus 3 plus minus 4.85 gives me about minus 6.85. Right? So minus 6.85. Alright, let's just check that again. Let's go up instead of down. So I'm going to do minus 4.85 plus 3 plus minus 5 equals minus 6.85. So minus 6.85 horizontal. Now the minus just means it's coming down. If that was plus, it's going up. So the horizontal, total horizontal force after all of that is 6.85 downwards. That's the way the horizontal force is trying to push it. Same with the vertical. We're going to do minus 7 plus minus 8.75. Obviously, you haven't got to use a calculator. You can do it in your head if you wanted to. Gives me minus 15.75. Minus 15.75. Right. If you want to check again, always check. We'll go minus 7 this time. Obviously, we're just adding these numbers up, really. It's just that some people may get a bit confused with the minus. There we are, look. 15.75. So, there's that, and there's that. All we've done now, I've just added these up. I've added all these up. I've added that, and I've added that. Come on, pen work. I've added this up to this. I've added all these up. So now, all that means is, right, is this. FH is minus 685. And total vertical force is minus 15.75. Don't forget, these are all kilonewtons. Kilonewtons, right? They're all kilonewtons. Kilonewtons. What that means in real life is this, is that the horizontal force is minus. It's not a minus, it's not floating, it just means this again, look. That and that. So it's just going this way. It's going that way because it's minus, and that's minus. It's going this way, 6.85 kilonewtons. Going that way, minus 6.85 kilonewtons. And the vertical has also got a minus in front of it, which means it's coming down as well. It's minus. So it's coming down like that. 15.75 kilonewtons. Kilonewtons. That's all it means. Don't put the minus in. All the minus tells you is the direction. Okay, or nod if you agree. So, after all that means is that, where is it? This thing here is going to be forced down, right? It's going to go down something like this. It's got to go down something like that. And it's got to come down like this, isn't it? So it'll come down like that, something like this. Again, not to scale. It's going to come down like that with the resultant force F and an angle like this. So what's this? North, south, east, west. So southwest if you want to put a direction to it. But we'll just use the angle. which means that if you were to draw that on here, let's get a really big thick line. But this thing is going to be coming down something like that. That's what it means. Now we need to work out the angle because we've done the direction. We need to do the angle and the size. Can I press undo? No, I don't like it. Anyway, I'm scared to do it. All right. That's what that means. Can I wonder if I can do that? Can I do that? Undo, redo. I thought you should undo that big thing. Right, so we know the direction. Has it gone from here now? No. We know the direction, something like this. We need to find now the angle and the size. Now there's two ways we could find f. So we need to look at that. Get rid of that. We need to calculate f. Let me spend a bit bigger perhaps. Calculate f, which we can do. There's two ways we can do it. The way we're going to be doing it is going to be using Pythagoras. Pythagoras. You could do it Pythagoras. We will do it with using Pythagoras. Come on, pen, work. Because there's a triangle. If you look, it's just a triangle. Or you could scale draw it, which you can if you want. I'm not going to. So if you look on here, when we use Pythagoras, here, look, here's my triangle. I'm going to draw in a bit. Here's a triangle. That's the triangle. There's that f. This line here and this line here. That's all we're going to be doing. Now we don't know the f yet, but we know this side here is 15.75. It's got to be in it. It's got to be. Because these should line up, really. So there's my triangle, 15.75. There's my f, which we're going to work out in a bit. And there's my 6.85. So let me draw a triangle. So I've got a triangle like this, and I got a triangle like this. And them two numbers were 6.85 and 15.75. So 6.85, just a length, all right? Just a length, 15.75. Obviously, they're forces, but as far as for this, we could just treat them as a length of a triangle. 6.85 and 15.75. Alright, because this length here is 15.75, which means this has got to be 15.75. We could draw this length in here. That's got to be 6.85 as well. Just my triangle. We need to find, alright, let's do it red. We need to find this resultant force here. Label it F. And we need to find the angle of the dangle in there. So all I've done there is, it's just this triangle here. It's just this, there's my F. It's just this triangle I've drawn. That's all I've done. It's triangle. So I'm going to use Pythagoras now. I'm going to swig a tea first though. I'm going to use Pythagoras to find that F. Now, hopefully you know Pythagoras. I'll just refresherize your memory a bit. For example, I'll just do it the way you may have seen it before. So there's that, and there's that, and there's that. 90-degree triangle. This is called the hypotenuse. All right, in a bit. Longest side. Now, you may have also seen it labeled as A when you're doing Pythagoras. Side A, this could be side B, doesn't really matter. Side C. You can use Pythagoras to find this A. Because don't forget, this line here, this here, is really the hypotenuse. So Mr. Pythagoras said a squared equals b squared plus c squared. So in our case, this is going to be f, isn't it? Isn't it? Isn't it? Isn't it? Isn't it? Because this length here is the same as a hypotenuse, and we've got both of these sides here. So what we can do is we'll call this f squared. F squared. Come on, pen, work. F squared equals b squared. Well, I'll call this b squared. 15.775 squared plus the other one plus c squared 6.85. 6.85. Need to press it a bit more, I think. Are you with me so far? Are you with me? Just Pythagoras. I think there's a video on this on my channel somewhere, but Pythagoras is Pythagoras. We should know about Pythagoras. So obviously, if I want to find f, I'm just going to do this. The opposite of a square is a square root, so I'm going to square root all of this shamonga. 15.75 as a 5 squared plus 6.855 squared. Opposite of a square, square root. So I've square root all of that. That's going to give me f. Give me size of my force. So on your calculator, do this. Do it all in one go if you want to. You can do this. Press that button there. And then go to 15.75 square plus 6.85. 6.85 square. Press the button. 1717. We'll have that, shall we? That'll do me. So that is saying that the resultant force coming down is going to be 17.17 kilonewtons. So this thing in here is going to be 17.7 kilonewtons. Now, let's just do that again. Do it a different way. So you can do this. You can just do this. 15.75 squared. You can then do plus 6.85 squared. That gives me 295. Say, I'll just round that up. So 295, and then square root of 295, just to see if I'm right. Now, yeah, obviously, if you do it all in one go like that, that's the best way of doing it, because you haven't got to, it's a bit more accurate because you haven't got to round things up, because we're rounding up quite a lot here. But, just always try and do it twice to make sure you get the right answer. 3 times now, 1717. Thank you very much, everyone's a winner. All that really means is this, that this thing is going to be coming down something like this. Resultant force of 17, come on pen, 17.7, right? That's a 7 kilonewtons. Now we need to find the angle in here. We need to find the angle, which we can. Again, all I've got is a triangle. I've got 6.85 there, and I got 15.75 there, so I can still draw this triangle. So we can still put this triangle in. So we can still draw this, because we're going to have to draw this in a bit. That's one side of my triangle. This is the other side of my triangle. Obviously, they should meet like that, perhaps. So one's going to be 685 and 1575. So this is 6.85, and this is 15.75. 15.77. With me, there and there. And we know this is 1717. Obviously, this is not to scale, because so 1717 kilonewtons, 15.75 and 6.85. Now we need to find the angle. Now hopefully you've done a bit of this before. Let's get a black pen. Sokotoa. Come on, pen, work. Sokotoa. Right. Sine and cos and tan. Triangles. So we need to find this here. Now we know all the sides. We know all the sides. So label the sides if you want to. Obviously the longest one is the hypotenuse. That's going to be 17.7. This is opposite here, opposite the angle. And this is the adjacent. It's adjacent to the angle. So because we know all of the sides, I'm going to, you can use what you want really. I'm going to use tan, and I'll tell you why I'll use tan. Because I've calculated, although I've calculated both of these and I've rounded up and things like that, I've calculated this 17.7 using Pythagoras. So, you know, I could have made a mistake, couldn't I? I could have made a mistake at the start, really, but I could have made a mistake with Pythagoras. So they always say try and use numbers you're given, not the ones you calculated, because you could have made a mistake. So I'm not going to use a 17.7 because I'm not sure if it's correct, because it may not be correct. So I'm going to use A and O, because I've sort of worked them out previously, so I don't want to make another mistake. So I'm going to use O and A. But you can use what you want. You could draw the triangle by hand and it would work out, or I suggest you use tan and then just check by using sine or cos, just to make sure you're correct. I'll use tan. So tan of the angle is going to be opposite over adjacent. Right. We know the opposite is 15.775, and the adjacent is 6.85. Now, obviously don't do this because this would be wrong. Don't just do this because this is wrong. Right. 15.75 divided by 6.85. Right, just don't just do that because it's going to be wrong. Right, the angle is not going to be that, because this is quite a big number coming down here. That's quite a small number, right? So it's not going to be 2.2. Don't forget you've got to inverse sine this, so you've got to go really tan to the -1 to find the angle. So it's going to be tan -1, right? Get rid of that. Tan of that 15.75. Here's my 6.85. Right? I'm going to go into that, but that's just how you do triangles. There's probably a video on this site somewhere on that, but that's just working out angles. Right? So make sure you do that, right? Because it makes me sad if you don't do that, because you'll be wrong. So what you got to do is this: shift, tan, and then do this, and do 15.75. Come down there like that. 6.85. 0.85. There we are. Leave the bracket perhaps like that. Press the button. 66 degrees. 66.5, say. Like my USB is slowly going. 60, look. 66.5 degrees. Which makes a bit more of a sense. So this angle in here is going to be 66 and a bit in there. Because it's not a scale, by the way. So you've only got a small 6.85, then you've got a big 15 coming down, so the angle is going to be quite big. Now what we can do is we can just check that, just to make sure. So I'll use cos or sine. If you use sine, I would let you vote, but so we can use sine of the angle. All right, obviously we're going to use sine -1, and sine is opposite over hypotenuse. So opposite over hypotenuse. If we get the right answer, we know we're sort of correct. So the opposite was 15.75. 15.75. Come on, pen. That's 75, right? And this is 1717. 17. You know, don't forget, you know, this is kilonewtons, but they're just lengths. I mean, so you could put the kilos in, but it just cancels out when you're doing this. So if we get 66.5 now, we know we're sort of right. So shift sine, do this, 15.75 divide by 1717. See what you get. Hopefully we'll get 66 or something. Close this, press that, 66.5. So, you know, I've done the angle both ways, so I'm quite happy that we're correct. So we've got 66.5 degrees. That is the angle. So after all of that, whatever this thing, what's this thing look like? This thing is, where is it? It's like an L bracket going that way. So what it is really is this. Here's my L bracket. It's called an L bracket because it looks like an L. Alright. And the result, we've done the resultant force and we've done the angle. So the resultant, well, the angle was 66.5, so we can put him in 66.5 degrees, obviously. The resultant force was what, 1717. 1717. 1717. Don't forget the kilonewtons. Newtons, right? Kilonewtons. And it was going like that. It was coming down like that, wasn't it? Southwest type thing. And yeah, it's coming down like that. Like that. So it's coming down a bit like something like that. What that means is, right, roughly, there's more we can do with this. Like we can do moments to work out exactly, you know, where this thing is, because we don't really know where it is. But it's something like that. It means this: out of all of them forces, all of these forces up here, all of these, that 5 and that 3 and that 7 and that angled 10. We've got a big 10 pulling it down there. Like we've got a big 10, we've got big 7, small 3s pulling it that way. So that's why it's coming down like this. So you could, if you wanted to, it's doing some. It's coming down like this. Ready? We don't know where really, but I'll just do this. It's coming like that. Why is it coming like that? Because we've worked it out. It's coming down like that. Here, done that. And we know the size of it is going to be 17.7 kilonewtons. Come on, pen. 17.7 kilonewtons, and the angle in here is 66.5. 66.5 in by there. In there. Because that's the angle we worked out, and it's in there, look. So that's the resultant force. The direction is coming down, something like that, and the angle from the horizontal is 66.5. So it's 66 in there. Right, that's 66.5. There we are. That's it. Really? So that is working out the resultant force, which is this. So you could label that the resultant force. That's the resultant force. Resultant. Come on, pen, work. Resultant force of 17.17 kilonewtons at an angle of 66.5 from the horizontal, going down that way, southwest, I suppose you want to call it southwest. We can do more on this, because we can do like a pivot point here to say is it twisting or turning or whatever, but that is in a future video. There are videos on the channel on things like that. But that is working out resultant forces, the direction and the angle of the dangle of that force. So, hope you enjoyed that. If you have, subscribe and like my channel, and there are various sciencey stuff on here. But for now, good night, over and out. Goodbye.